Good morning children. Today we will do the revision of pulleys, and the first topic that we will take is single fixed pulley. You all know that pulley is a machine which is used to lift heavy loads. Now single fixed pulley has fixed axis of rotation and hence is the name. In the diagram, it is clearly mentioned that one end of the pulley, the rope, there is effort, you apply effort, and the other end there is load. Now because of the forces that you apply on each of the rope, the tension is developed on both the ropes. So we can write the effort is equal to tension T, which is acting on this rope, and load is also equal to T acting on the other rope. The direction of effort is definitely downwards, as well as the direction of load is also downwards because of force of gravity. Now if I want to find out the mechanical advantage of this machine, then as per the formula, mechanical advantage is equal to load upon effort. So on putting the values, I'll get mechanical advantage of single fixed pulley as 1. Definitely here I have assumed that there are no losses taking place because of friction between the rope and the rim or for any other reason, and hence mechanical advantage is 1. However, in actual practice, the mechanical advantage of a single fixed pulley is never 1, it is always less than 1. But for now, we will consider the ideal situation only. So mechanical advantage 1 means this machine is not going to give us any gain, whether in speed or in force. That means you will never be able to use this machine for lifting heavy loads. This machine is used to lift lighter loads. But most important thing is that when this machine is not giving us any advantage, neither in terms of force nor in terms of speed, then what is the purpose of using this machine? The purpose is basically the direction of effort. If you remember when you did the functions of machine, one of the function was that a machine can be used to change the direction of effort to a convenient direction. So here the effort which is acting in the downward direction, that means you pull the rope in the downward direction, this simply is convenient to us because we are applying effort towards gravity, and this is the only purpose or only reason why we use single fixed pulley. Mechanical advantage 1 here means, therefore we can say that if the value of load is 100 Newton, if I assume that a 100 Newton load is to be lifted by using single fixed pulley, that means the amount of effort that I am supposed to apply will also be equal to 100 Newton under ideal situation when there are no losses taking place. Mechanical advantage 1, it also means that velocity ratio is also equal to 1. No gain in speed, no gain in force. So if I design now this particular pulley in such a way that I get gain in force, that means if I want to use a pulley to be used as force multiplier, then certain modification is required to be done in the diagram or in the construction. So this gives rise to the next type of pulley known as single movable pulley. This is the diagram of single movable pulley, and if you compare the first diagram for that of single fixed pulley with that of single movable pulley, what difference do you observe? In the first one, the pulley, that means the wheel, was fixed, but in the second one the wheel is not fixed. The pulley will move, it is movable. The second difference in the diagram you can observe is that the load in the first case was connected to the rope, but in the second one it is connected to the pulley itself. Third difference is the direction of effort in the first one is towards gravity, but in the second one is against gravity. That means you will have to pull the rope upwards in order to lift the load. Direction of load, that means the weight, the force due to the load will definitely be downwards because of the force of gravity. So this is the constructional difference between the two. So the purpose of designing a single movable pulley was to obtain mechanical advantage. The axis of rotation in this one is movable and therefore is the name. As I have said just now, the movable pulleys are designed to give mechanical advantage, which is the measure of performance for a machine. Having a mechanical advantage means the force applied by the machine, that means the load, is greater than the force which you apply. That means here, even if we will be applying effort against gravity, but the amount of effort to be applied will be less than the load, which does not happen in the first case. Here, if 100 Newton load needs to be lifted, then at least we will have to apply 100 Newton of effort. But here we will observe the things are different. Effort will be less than load. So let's see how is this possible. Again, this load here in the diagram you can see is supported by two strings. In the first case, in single fixed pulley, the load was supported by only one string. So the tension due to this load will be on both the strings, and there will be tension due to effort also, which will act on this string. Now that tension is not mentioned in the diagram, just to avoid confusion. So here the two tensions which I have mentioned here is because of the load, right? So that makes value of load will be T plus T, or we can write directly as 2T, twice of T, and effort, since it is acting on a single rope, so this will be equal to T. So from here, if we want to find the mechanical advantage, the value of mechanical advantage will be 2, load upon effort. So the value mechanical advantage equals to 2. This is a value greater than 1. What does this depict? When mechanical advantage was 1, the values of E and L were same. Mechanical advantage is 2. It simply means that now if you have to raise a load of 100 Newton, then the effort applied will be equal to only 50 Newton. That means half of the load, just because the mechanical advantage is 2. The load is supported by two strings. That means the tension, now the value of tension on both the strings is same, which means that this 100 Newton is equally divided into 2, equals to 50 Newton, and this will also be equal to 50 Newton. That means tension on each rope is 50 Newton, which is again lesser than the total load, and hence the effort which you apply to lift this load will also be less, and this is why this particular pulley will be termed as, or will be considered as, a force multiplier. I repeat children, this is the ideal situation where we are considering that there are no losses taking place due to friction or any other reason. But in actual practice, the mechanical advantage of a single movable pulley will always be less than 2, but definitely greater than 1. That means in any case it will give us advantage in force. This is one thing. Now comes the next important point related to velocity ratio. The value of velocity ratio and mechanical advantage are same in ideal situation. That means velocity ratio is also 2. Now you must understand the term velocity ratio with respect to both the pulleys. Now here in the single fixed pulley, if I want to lift the load by 1 meter, then the effort will, that means the rope, when I'll pull this rope downwards, the distance moved by the rope will be equal to 1 meter. That means the value of dl is equal to value of de. Displacement due to load is equal to displacement due to effort. But here the velocity ratio is 2, which simply mean that if I want to raise the load by 1 meter, then the effort needs to be, the displacement due to effort should be 2 meter, which simply says that a machine which is considered as a force multiplier comes at the cost of speed. The greater the value of MA, the lesser the distance the load will move with respect to the effort. That means now you will have to pull the rope twice the distance of that of the load. This is the basic meaning of the value or the term velocity ratio. Before we go further into the topic single movable pulley system, which will overcome a few drawbacks of single movable pulley, let us once again see the difference between the two. First of all, the pulley, the single fixed pulley has its pulley fixed, while the second one, the pulley is movable. Mechanical advantage in the fixed pulley is 1. Here the mechanical advantage is 2, which is just the double. That means this is acting as a force multiplier. But even though the movable pulley let you lift a heavy object with less force that you would have to use with a fixed pulley, you still had to move the pulley farther, and this is shown here, which does not happen in the case of single fixed pulley. However, the major drawback of the single movable pulley is that the effort which you apply is against gravity. First one has its advantage that the effort is along the convenient direction, but it was not giving us any gain in force. The second one has the advantage that it is giving us the gain in force, but the effort is applied in the reverse direction, that means the against gravity. So the third one, which is a modified version of both of them and better definitely, which is why, and since it is consisting of two pulleys, one is fixed and the other one movable, and that is why it is called single movable pulley system. This was single movable pulley, but this is a system of two pulleys, one fixed, another one movable. That means now we have joined both of them to overcome the drawbacks of the previous two versions of pulley. You can see clearly over here that effort is applied in the downward direction. This we have obtained from the fixed pulley part, and the movable pulley which has load, and this load is also movable. Now this is supported by two strings, and therefore the mechanical advantage of the single movable pulley will be 2. Which is more than 1, and hence can be used as a force multiplier. In this one also, the tension is going to act on all the strings. Effort is applied on this rope, therefore tension is across this in the upward direction. Load always acts in the downward direction because of gravity. Therefore, tension will be in the upward direction, and it is equal in both the strings. So if I want to write the expression of L, it will be twice of T, and E will be equal to T. And this is same as the previous one, and hence the mechanical advantage of this machine will also be 2, which is again same as the previous one. But here what advantage are we getting? the advantage is that the effort is now in the convenient direction. So the concept, the rest of the concept of single movable pulley system remains the same as that of the single movable pulley. The only difference is that now effort is in the convenient direction. Hence, if I have to lift a load of 100 Newton with the help of single movable pulley system, then the effort which I will apply is only 50 Newton, half of the load. The tension here will experience the load equally, and hence T value will be 50 Newton as mentioned earlier. Velocity ratio will also be equal to 2, and what does this mean? That means here also, if you want to lift a load up to a height of 1 meter, then the rope on the effort side needs to be pulled down by 2 meter. That means it has come at the cost of speed. So these are the three basic pulleys: single fixed, single movable pulley and single movable pulley system.